এটা ভিডিও কে इन्हें इन्हें देखा जाएगी এটা আমরা চেক নেব সবুজ হ্যালো কর্মা so let us start the program. I officially inaugurate today's webinar, which is an international webinar, and I accord the sense of gratitude to our resource persons, Professor Sarira Sahu, Institute of Nuclear Science, National Autonomous University of Mexico, and my friend Professor N.K. Sharma, Associate Professor of Physics, SOA. I must congratulate the HOD Physics and his associates and the IQAC coordinator for organizing an international webinar, and that too in the topics of coming under the Department of Physics. And I hope that all the participants will be immensely benefited with this webinar, and will also be interested to hear more in the coming future from these resource persons whenever they find time to cooperate, and definitely we'll be hearing them. Now I wish today's webinar a grand success, and hope that our student friends also will be benefited by joining this webinar. Thank you. Now I request Head of the Department of Physics, Professor N.K. Misra, to introduce our guest, Professor Sarira Sahu, who will speak on a very beautiful topic, which I think messengers from heaven.
Messengers from heaven.
So I am as a biologist, I think I was trying to whether this is definitely I will be also benefit, and I'm grateful to Dr. Sarira Sahu and now the Department of Physics, our first resource person, Professor Sarira Sahu, Dr. N.K. Misra. Professor N.K. Misra.
Hello. Audible hoche? Honorable Principal, distinguished resource person, Professor Sarira Sahu, and resource person for the second session, Professor Nachiketa Khamari Sharma, distinguished guests, IQAC coordinators, respected colleagues, and dear students. First of all, I would like to welcome you all to this international webinar. I have been assigned the duty to introduce the resource persons. Our resource person for the first session of the webinar is Professor Sarira Sahu of Mexico City. Before introducing him, I would definitely like to thank him for accepting my request in spite of his very busy schedule. Professor Sahu actually needs no introduction for persons who are related to astroparticle physics, neutrino physics, high energy cosmic rays, physics of gamma rays burst, or finite temperature field theory of the world. Professor Sahu has proved that all obstacles on the path of success fails against determination. He is a highly determined person. Actually, he hails from a very small village named Dholban near Padampur in the district of Bargarh. He has completed his BSc degree in physics from Anchal College, Padampur in the year 1984. He completed his master's degree from PG Department of Physics, Jyoti Bihar, Sambalpur University in 1986. He pursued diploma in advanced physics in 1988 from Institute of Physics, Bhubaneswar. He has completed his PhD from Institute of Physics, Bhubaneswar in 1994. He prepared postdoctoral fellowship in different institutes like University of Valencia, Spain in 1994-95, Physical Research Laboratory, Ahmedabad in 96-97, Institute of Plasma Research, Gandhinagar in 1998. From the year 1999 onwards, he is working in the Institute of Nuclear Science, National Autonomous University of Mexico in Mexico City, and presently he is a professor of physics in that institute. He has also served as visiting professor in different advanced countries of the world like USA, Spain, Japan, Italy, Austria, Colombia, Taiwan, China, South Korea, and Japan. His area of research are physics of neutrino, high energy cosmic rays, gamma rays, and matter under extreme conditions. To his credit, he has more than 65 publications in international journals and numerous publications in national journals. And he has guided 6 master theses and 2 PhD theses. Actually, this is a very brief brief introduction of Professor Sahu. Lastly, I must tell all of you that I feel very proud to be one of his PG mates. He is a very close friend of mine. Although he is a man of world repute, still he is sober, polite, and a fine gentleman. He is having a very strong willpower. I still remember his speech in the welcome ceremony of our MSc classes in Jyoti Bihar, where he had told that his aim in life is to pursue research in physics, and he will start his research from Institute of Physics. Those days, it was a very high dream, and he did it. That means he is determined and extremely determined, I would rather say, extremely determined. Journey from a remote village like Dholban to Mexico City in 90s is not a matter of joke. Salute to his determination, Professor Sahu. He is definitely a source of inspiration for all of us and also for all the students of these remote villages. Today, he is going to discuss about different messengers, that is messengers or heavenly messengers, discuss about different messengers which bring information from distant objects like stars, galaxies, black holes, etc. to us on Earth. Using these messengers, he shall try to make us understand the violent mechanisms in these objects. He shall also focus on the production of extremely high energy cosmic rays, which are impossible to produce on Earth. We will also discuss the recent developments in these fields. And I know he is having a very busy schedule. Still, he accepted my request, and I am again thankful to Professor Sahu. And sorry for the delay in starting the webinar. And now I would like to request Professor Sahu to enlighten us on the above topics. Professor Sahu. Request you.
Kind classmate, so we are very close, although we have not seen for a long time. So I am thankful to him. And also I am thankful to Professor Devraj Mishra and Mrs. Arti Panda for kindly accepting me to give a seminar. Well, first of all, I don't know how to show my transparency, so please tell me how to present that. Present your entire screen.
Screen share करो
Share the screen. You want to show your transparencies?
Yes.
Just a minute. Present, just come present now.
Present now, okay.
Present now.
Then your entire screen. Then you know.
And entire screen.
The recipient is basically a messenger, whether in the, you can tell them stars, they will give billions of times more energy in few seconds. But fortunately, these stars, these systems are quite far from us. Otherwise, they could simply annihilate us. Okay. Then there is another one, is called gamma ray burst. This gamma ray burst is the object which is basically formed when there are special type of stars when they collapse, and that collapse will produce trillions of times more energy than the sun produces during its whole lifetime. And these are being observed almost every day. They are observing around 2 gamma ray bursts in the universe by satellites experiments. Then finally the Big Bang, which is the source of everything. So this is the one which has produced so many interesting things, and still the footprints of these are there. So they are also basically the messengers. Okay. Sorry. Okay. Then the next one. What do we learn from them? So from this source and the messengers, we learn mechanism of particle productions, how particles are being produced there. How particles are being produced there. Matter content, what type of matters, because probably everybody knows whether it is a science fiction or it is just a popular news that our universe contains only 4% of matters and all 96% is void. Basically, there is nothing. So what is that nothing? basically that is one of the challenging question in physics which people work on. So that is what it will tell about matter content, acceleration mechanism, because these particles are coming from billions of light years, millions of light years, quite far from our galaxies. So how do they come? What is the how these particles are being accelerated? So this mechanism also will tell. Energy extraction mechanism, because these particles, the one which I am going to talk about, they are extremely high energies. It is almost, well, not almost, it is impossible to produce on Earth, even though we have state-of-the-art technologies, but we cannot produce these particles. Like, for example, there is an accelerator, probably many people, they know, in Europe, that is called CERN, between border of Switzerland and France. So this can produce particles, extremely high energy particles according to our standard on Earth. And the particle which I am going to talk about, that will be billions of trillions of times more powerful than what we produce on Earth. So basically, if you want to produce such type of particles with the present technology, we need the size of our solar systems as an accelerator. So that is impossible. So we cannot produce that. So we have to depend on the nature which is producing this. And if we can detect them, then we will know about the sources and all this mechanism, whatever is working on. Then working of the universe. So basically how the universe works, these particles can give us information. And dark matter in the universe, as I told you, the matter content, dark matter in the universe, because some of these information, some of these messengers which are coming, they will tell about the dark matter content of the universe, because that is what the decay and all this process will go on, and then probably we can get some information from there. Okay, so now you see in the universe, whatever we see in the light, so far as the electromagnetic spectrum is concerned, only can you see my pointer? Excuse me, can you see the pointer?
Okay, it is
Yeah, okay.
visible.
So
Yeah,
so this is the region where the color is there. This red, yellow, all these colors are there. This is the region where our eye can see. Okay, so and from 10 to 4 to 10 to 20, only this much we can see. The rest of the thing we cannot see. Our eye cannot see these things. So to see all these things, if you want to know the universe, you have to know the universe in all energy spectrum, all frequency spectrum. So you have to know how it should look like in the left, and you have to know how it should look like in the right. So basically the left is low energy and right is high energies, and extreme right is extremely high energy. So mostly I will talk about extremely high energies. And this is the scale you can see. For example, if you are in the low energies, the radio wave, where you can see the buildings and human beings, this is the size of this one. Microwave, maybe these insects. Then infrared is still smaller. Then visible is a little bit smaller. Then you go on, and the gamma rays will see the atomic scales, okay, atomic and nuclear scales. So this is what, if you want to go the higher in energy, you have to go in smaller in distance or length scales, okay. Okay, now let's come to the physics part of this one. Now, in the universe, what we normally observe, the matter content of the universe is basically very, very strange. Only you see this table, what it is telling, the quarks, which are up and down, these are the only two particles which form the protons and neutrons, or you and me. Our earth, our water, whatever you see, they are made up of U and D quarks. Basically, protons and neutrons are made up of these two. Then the electron, and this is a neutrino, this particles, which is strange particle I told, electron neutrino. So if you see, there are three families: family number 1, family number 2, family number 3. So there are three families, but only mostly you will see in nature the family number 1. 2, 3 are not seen. These are seen when there is collision, and you produce that. In universe, it is produced when there is a collision, some violent process goes on, then only it will be produced. Otherwise, normally you see is this first family. Okay, and these are the particles which are associated with the force. Like for example, when you see the electromagnetic force, basically electromagnetic force is, let me tell you, when you cook in your house, whatever cooking you do, there the electromagnetic force is applied. So photon is the one which is responsible. If you are talking about weak force, which is this G boson, which is responsible, and W bosons. Actually, there are two types of W boson, W plus and W minus, and Z is the neutral boson. And if you are talking about the strong interactions, nuclear interactions, this is the one which is responsible. This is called gluon. Okay, so there are 8 types of gluons, but forget about that one. You don't have to worry about that. And now if you see the right hand side, apart from that, everything is the same except that the last one, Higgs boson. Basically, people, they know this as God particles. Okay, so nobody knows about Higgs, but they know about God particles. So this is the particle which gives us mass. If this particle is not there, then there is no mass. Okay, basically that is the one. And this was the most sought after particles, which was looked for 40 years. And very recently, 8-10 years ago, this particle was discovered. Okay. Now, let me come to the messengers. Why do you study these different type of messengers? One is not enough. Well, simple answer is no. One is not enough. Why? Let's see. This is our Earth, and this is a source. It doesn't matter what type of source it is, but let's say this is the source which produces all type of particles. What happens? If you are, let's say, first you talk about the gamma rays or light. These lights will come to us very nicely because this is a neutral particle, so it can come and it has mass 0, so you can come from the other end of the universe. It can come, so practically there is no problem. But what happens if the light or the energy of the light increases? Then this light will interact with the background light, which I am going to tell. Background light, which is called interstellar medium, background light. And in that background light, these high energy gamma rays will split to electron-positron pair, and then basically it will vanish. So you will not get any information from here if you are detecting these high energy gamma rays. They have a limited distance to cover. After that, you will not see. Okay, so this is the one which will not give you any info. Low energy one will give you information, but anyhow, if suppose for example, if you are getting low energy gamma rays from the or photons from the sun, it will tell only the surface properties. It will not tell the internal properties. Okay, now let's take the protons, which are basically cosmic rays. So if the cosmic rays is again very high energy, low energy they can come, but again because there is a magnetic field here in between the source and the earth, so what will happen? Will deflect these charged particles. So instead of coming from here, this will go, instead of coming to the earth, this will go somewhere else. Or let's say here there is an object, it will come from this direction, so you think that it is coming from through our body. Every second, every square centimeter, billions of neutrinos are passing through, and we are grown up with this one. So particularly from the sun, they are coming billions. Okay, from other objects they might be coming, definitely they are coming, but there can be extremely high energy neutrinos passing through us also. So but most of them will not interact. So what happens is that if these neutrinos are produced, and they are produced only in nuclear interactions, so when they are produced, they will almost not interact and they will come to Earth. By chance, if we are able to detect these neutrinos, then we can know something about these sources. So that is precisely the one which are being the technology is being used to detect this type of particles, neutrinos, to know about the source, the production mechanisms, the matter contents, and all these things. And there is another one I told you, the gravitational wave, which, well, I don't work on that one, but at least I can comment on that one. That is basically what happens is that when two, let's say, two stars or two black holes, when they somehow interact and collapse to form another black hole, then that time they will disturb the space-time. It is like you are throwing a stone to a pond, then it will create a wave. So this is what precisely it does. And these effects are so powerful, so massive, they will simply disturb the space-time, which is the fabrics, and that disturbance will propagate from that place up to us, and that has been detected very recently. Okay, but that wave which will come, the frequency of that one will be extremely small, extremely small. So this is of the universe. This is the big universe has already gone through of stars. Now this is after the 175,000 years after the Big Bang, whatever was formed. This is the light which was formed during that time. Now this light is measured extremely precisely. You can see these are the data from the experiments, and these are the theories. So we know what are these things. Actually, you are different colors. They are basically the fluctuation, matter fluctuations. And you see these fluctuations are basically the formation of stars and galaxies and this one. Okay, so this one which is visible, that sometimes you may not be able to see very high energy cosmic ray places. Okay, now detection of very high energy particles on Earth. So this is a clone, you can see this. Normally what happens is that when they put the oxygen and nitrogens, because these power particles are smash this part nitrogen molecules or molecules, and they will produce millions. These millions of particles are then which I am going to discuss about that one. Now, start as I told, how do we do where do we the gamma telescopes are high energy. Okay, so this so and it is electron to 100 tera electrons. Okay, and the second one is called in Africa, Namibia. Again, this is the energy range. And then you can see what is better. Biological detectors. It is in Mexico, something around 100 kilometers from my house where I live. So, and it has a range from 100 giga electron volt to 100 tera electron volt. And these are basically water tanks through which they detect. And if you see the frequency of this, they will only 3 Hegra, very long, there is no. Then it detects. it will work 24 hours. Okay, how whether it is source or somewhere else. Instead of they come and produce hour. This is called star. And they produce the photons or light, light being detected by photons and to a produced when refracto. So this is the telescope. Basically, these are water tanks. These are water tanks. When high energy photons comes, produces the low energy, and these will be going through this one water tanks. But there are detectors in the water tank, and they will they will right timing, directions, everything will be reconstructed from that one. Okay. Okay. Sources of very high energy gamma rays. I told you that active galactic nuclei are basically galaxies which are having a supermassive black hole. Supermassive black hole in the sense that there is a black hole of the order of 7 to 10 to 8 times the mass of the sun. Black hole is sitting there, and it is eating everything. Whatever is coming on the way, it is eating. And when it eats, actually particles are accelerated past that, and it produces jets, which I'm going to show you. And that in the jet, these particles, which is we are seeing through this, and that is what is being. I mean, we have seen that one. Okay. Then gamma ray burst. This is another thing. Gamma ray bursts are produced when special type of stars, when they collapse, die, they produce extremely powerful signals, and they produce a black hole in the center, and these gamma rays are observed. So that is also there. Then pulsars. Pulsars are basically neutron stars. When again a star dies during its mass, it can produce a neutron stars or gamma ray burst, white dwarf, whatever that you tell, depending on their mass. And these pulsars also produce high energy gamma rays, not very high, but high energy gamma rays. And these pulsars are the objects which nature has made so precise in timing. Their signals are so precise that few million years it will have a difference of maybe 1 second. So these are clocks in extra. Then also, if we don't know what type of dark matter exists in nature, but we know there is some matter which doesn't. We don't know about them, but they constitute almost 96% of. So if that is one, probably some of this dark matter may decay, and they produce high energy rays. Now, as I told you, active galactic nuclei basically. What I am studying is this black hole. All these are going to this one. They will pull jets. They are producing in opposite direction. Somehow, okay. If you are here somewhere else, then this. Better pictures. So this is the black hole, which is eating this. In the somewhere else here, then you can see these blasters. Well, I am talking about millions of years. Like you don't have to, nothing will happen to you. So if we are somehow here, then we can see the variation in or fluctuations in all these matter. Okay. So these photons or light it will produce, and the particular flick this photon out, and these photons will be boosted in energy. A second. What happens? But they have seen that there is something going on in these objects, some of these objects sometimes, okay? Like, for example, they have, but they didn't know why it is coming, okay? Then they thought that maybe electrons, still higher energy electrons, not gamma rays, low energy photons, and produces the delta resonance. Probably physics, they know what is delta particles. So the particles will produce, this is a resonance, and this resonance after into this process, fractions which are produced. Now, I have, so this is like, for example, the peak, well, this fraction, well, second peak, sometimes it will go up because intense. This is the atmosphere. It produces all this junk, and this junk can be detected by this one. Depending on the time, they can see from which direction they are coming, because they are real-time detectors. And so this is one of the looking like this. So because once it hits this detector, it will automatically broadcast that message telling that at the time I have this. Then there will be another one, and there is a distance of 1.5 kilometers between these two detectors. Okay, so then they will see, for example, if you have seen this one, it has a, and when it comes to it takes the timing, so from reconstruct the directions. Okay, but there are uncertainties. So this is the Pierre Auger Observatory in Mendoza province in Argentina. You can see this. This is the size of this one. Actually, they have put in this, like, for example, these are the as I told you, from here, if you are working in the laboratory, these are the what type of neutrinos they see. That is not important. So now it is a clear picture of Super Kamiokande, and this Sudbury Neutrino Observatory in, just show you that you should have an impression how it looks like. Okay, this type of interactions takes place: charge, current, neutral current, that is because this is one. Then another source of neutrinos is supernova, which neutrino events we detected, and that confirms. And now the detectors are so precise. If there is a super on the events, and maybe our theory will be proved there. Okay. So they have already, these theories are correct. Supernova explosion nearby universe. We can test our notes from him. This is extremely neutrinos. The other thing is, I mean, it is like this one, which I am going to tell that, but it is a reality. What do you mean by I? As I told you, we need huge detectors, but then we need resources, we need money, we need everything, and it is not easy to get all these things. So the detector, so you can see that it is 1 kilometer with the base. If you are lucky, they will interact. If you are not lucky, they will go. So few of them, maybe out of one will interact. So that one, when it will interact, so it will produce now, and the light signal when it passes. it will produce image detectors, photomultiplier tube will capture these lights, and they will send this signal. So you can see that it is like a movie. You can see that one, and then that will be recorded, and then from there and they will tell that. So now so far they have already seen I think around 200. Oh.
Hello. Hello, Sarira. Hello. Hello. On আছে, on করেছি। Hello. আমার নেটওয়ার্কের প্রবলেম আছে ভাই। কিছু নেই সুব্বা। No, no. কোটি তো
স্যার কোটি
ওভারকম করনি না।
নমস্কার।
কেন গরমে না লাগে এটা মোট কম করছে হলো হলো করছেন শুন
when it is coming, it will interact with this low electric background light is basically CIB plus optical plus UV. These three. Okay, these three. So when they come here and they will interact with these photons, they will produce electron-positron pair. Okay, so once they produce electron-positron pair, then this particle, this high energy photon is lost. Is that okay? Here, maybe look here. One of this photon is high energy. Another one is this EBL, extragalactic background light. So they will hit both of them. This is called Feynman diagram. I don't know whether you understood or not. This is called Feynman diagram. So this will produce a electron and a positron, and they will simply go.
Okay, that electron positron is dark matter. They are calling it as.
They are called antiparticles. Positrons are not dark matter.
So they are created from it or something like.
They are created. They are created from that.
Okay,
Now question is, you can ask that where is that positron? Well, this is another question, because you see Hindu mythology, probably you know Shunya, there is nothing, okay, vacuum. But vacuum in physics is the one which is rich in everything. It is full of particles and antiparticles. So the vacuum which is full of electrons and positrons, but they are in tranquilities. What happens if your energy is very high? Well, of course, when only high energy gamma rays goes and it will interact with the vacuum, nothing happens. But if you have a photons here, and if your kinematical condition is sufficient enough, for example, I cannot tell you to run 100 kilometers per hour because you have no capacities like that. So anything which is not capable, kinematically allowed, it will not produce. So this photon and this photon has to satisfy some conditions. If that condition is satisfied, then you will produce this electron-positron pair and they will simply go out. So this electron probably will go, and these positrons, once it is produced, maybe it will interact with another electron and annihilate, and it will produce another photon. But that photon will be different from these photons. So, but positron is not dark matter. This is the antiparticle of electron. Or you can tell anti-electron. Normally they don't exist like this, but they are produced in interactions. Collisions, they are produced, but normally you don't find them.
Actually, I want
Professor
to
Sahu.
ask. Hello.
Uh-huh.
One last question.
Yes.
Okay, Professor
Any
Sahu.
more questions?
Professor Sahu.
Yes,
I
yes,
think
yes.
we shall now
Okay.
session start. Or will you like to answer any questions? Somebody has asked a question. Sir, can antimatter from antiparticles
Antimatter exists
from
from?
antiparticles?
I told I answered that questions. Antimatter
Okay.
basically is coming if you anti-hydrogen is basically you take
Okay,
antiproton.
I think that part is over. Okay, Professor Sahu.
Okay. Yes, yes, yes. I can.
So this is all about your talk, I think. To suggest, pause.
Well, well, there are many things I can suggest. Your introductions. So nothing is impossible. If you work hard, you can do better. I mean,
It will only be the key to success. Thank you, Professor Sahu. In spite of your very, very busy schedule, you have given us time. Thank you, sir.
Yeah, welcome.
Thank you.
Thank you.
Now we shall start the second session. The guest has already arrived, and before he is going to deliver a speech on the traditional science and technology of India. This is entirely a different topic, and I will not let you. I will first welcome Professor Nachiketa Khamari Sharma of ITER. Sir, am I audible?
Yes, yes, you are audible.
Okay, okay. So let us introduce Professor Nachiketa Khamari Sharma. I would like to thank him before introducing for accepting my request to deliver a talk in this webinar. Professor N.K. Sharma has a long teaching experience of 31 years in different institutions, starting from plus 2 level to MSc level. He has completed his BSc degree from Rajendra College, Bolangir, and MSc degree from PG Department of Physics, Sambalpur University, Jyoti Vihar. He has obtained his PhD degree in physics in human photoreceptor optics. He has served in Anchal College, Padampur, Sonpur College, Sonpur, Aeronautics College, Sunabeda as a lecturer. He has also served as principal in the plus 2 college of ITER, that is IHSE, Bhubaneswar. Presently, he is working as associate professor in ITER, SOA, deemed to be University, Bhubaneswar. He has, to his credit, 21 research papers in reputed national and international journals. He has presented 3 conference proceedings in international seminars like WRAP in 2013, that is in IIT New Delhi, ICOP 2014 in Kolkata, VPO, that is Visual and Physiological Optics, VPO in 2016 at Antwerp, Belgium. He has participated in more than 40 national and international seminars, workshops, refresher course, and orientation courses. He has authored 3 books, namely Compensative Retinal Response to Loss of Luminescence Efficiency by LAP Lombard Academic Publishing, West Germany. Number 2, the Smart Materials in Physical and Biological Applications by United Scholar Publications, USA. And the third one is Understanding Internet by Silicon Sahitya, Bhubaneswar. And he has also authored 3 book chapters in internationally and nationally published books. Presently, he is guiding 3 research scholars for PhD and 3 for MPhil degree. He is a fellow member of the Optical Society of India, patron member of Orissa Physical Society, and life members of Orissa Vigyan Academy, Indian Association of Physics Teachers, life member of Indian Association of Nuclear Chemists and Allied Scientists. He is also the life member of Kedarnath Gaveshana Pratishthan. He has been awarded with Visvesvaraya Pratibha Puraskar for outstanding contribution to NSS activities in Engineers Day 2017. He has spent popular skills in Digbara, contributing regularly to ODI newspapers like Sambhad, etc. And is regular panelist in ETV, News 7, Nachiketa, and Konak News. He has acted as resource person for lecturers of STSC model schools and colleges in Mathematical Olympiad of Government of Odisha, Patani Samanta Planetarium, and also in Institute of Material Science, Nagpur. He is an acclaimed public speaker on popular scientific topics, in addition to contributing to Srujanika for last 2 decades. In addition to all these achievements, he is a polite, sober, and fine gentleman. And this, I must mention here that he is my big brother, a senior friend, and also a guide. Today, Professor Sharma is going to tell us about the traditional science and technology of India. Now, I request Professor N.K. Sharma to deliver a sparkling talk for which he is famous for. Professor Sharma.
Thank you, Nava, for your kind introduction. Actually, the introduction was very long, which I am not worthy of, but that is your love for me, respect for me. That's why you did not, probably you choose to be very lengthy. I am also thankful to Professor Sarira Sahu. I know him very well. We were friends in the university. He was probably 1 year junior to me, I think 1 or 2. So it's I was listening to the last part of his lecture. So he has excelled a lot in physics. Now,
just
my
a minute,
dear,
sir, just a minute. Your face is not visible. Half of the face is visible. Slightly adjust the camera slightly. Okay. Okay, sir.
is it okay?
Now you are.
So, but I am sorry that I may not be able to speak for 1 hour because I have got a important assignment at 1 o'clock. So I will take 50 minutes, and maybe for 2-3 minutes we will take 1 or 2 curiosity, not questions actually. and I have to go very hurriedly also. So the slides will be just at the background, and that will give me a direction, and I will go on talking to you. You see, so normally people have an idea that we have not particular or modern science and technology. It has also its harmful effects. And as all of you know, a single virus like this corona or COVID-19 has wrought a havoc in the worldwide. So whether you look to the climate, whether you look to standard and all this to important this ozone hole, all these things will point out that probably somewhere the Western science or the Eurocentric model, that is what is called Eurocentric model of development, has failed somewhere. So people look for different kind of alternative, isn't it? And at the same time, during those period, the innovations like gobar gas and the Chipko Andolan in India forced people to look for different innovations other than non-Western societies, and they tried to find out, is anything worth finding out in our own scriptures, in our own literatures, and that led to a vigorous work for the last 2-3 decades. And normally what happens, not in India, but in Africa, in all non-Western countries, all the contributions of non-Western countries, all their traditional technology, particularly people educated in Western science, they don't take it for science. That is one of the most unfortunate part of our learning system. All these actually happened by a single book, and that book is called Dharampal's Book on Indian Science and Technology in the 18th century. It has 17 chapters. All chapters were European account of the science and technologies as practiced in India in the later part of 17th century. So all the authors were European authors, and and the subject matter were the science and technologies of India in the later part of 17th century. Why I tell you all these kinds of things? Now you see, there was a man called Lord Macaulay, and Macaulay on 2nd February 1835, he gave an address to the British Parliament. I am quoting Macaulay's address so that you will be feeling that the great accuracy, the construction and even of the theoretical part of astronomy. Yes, is it visible?
Yeah.
Okay.
Please continue.
Yes. So Playfair in that Dharampal 17th chapter book, one chapter that is Remarks on the Astronomy of the Brahmins, he is telling that the construction of these tables implies a great knowledge of geometry, arithmetic of the theoretical part of astronomy. Book, Hindu algebra, he mentioned that the trigonometry, geometry, arithmetic, India has excelled like anything. But this gentleman, somehow I did not understand why he say probably that the knowledge, probably the Indian had borrowed this knowledge from Greeks. But in the same time, in an Edinburgh review, it was mentioned that rather the other way around has happened. That has been, knowledge has been transmitted to the Greeks from India and not from Greeks to Greek to India. Now, Dharampal's book on Indian science and technology has 3 chapters on the indigenous production of iron, whose steel of very high quality India was producing. India has 10,000 iron and steel furnaces in late 18th century with 20 tons of annual production. 2 chapters on the Indian method of inoculation against smallpox, and that was spread throughout the country and giving results. The Indian method of inoculation against smallpox. Remember, chapters on the making of mortar, paper, ice, and also traditional practices on agriculture. Shorter accounts of dyeing, surgical operations, materials used in building, and so on. Now, also, this Dharampal's book on Indian science and technology has motivated lot of people to take interest in academic work related to astronomy, mathematics, chemistry, agricultural practices, Ayurveda, and architecture. Lot of researches are going on during last few days in the last few years in these areas. Interest in non-Western science, technology, and medicine, not only in India, throughout the world, that is a very welcome sign. Actually, that is a welcome departure from the Eurocentric worldview, questioning the dominance of the modern paradigm of development. This is very important. The kind of development that we have taken, what are the parameters, or what are the parameters of development? Is the development sustainable? The way we are progressing and we are calling us developed, is that the right way? So these questions are being asked, and which are very important. And as students, as learners, we should not think that as far as getting a job is required, that is just one aspect of learning. Learning has other objective. So one of the reasons, so that is here Dharampal is also telling that one of the reasons for this is the lack of awareness about the traditions in society at large, our educational system. So of course, the new educational system is a very welcome change in that direction, but the educational system, how far that will be implemented and how that is going to give us a better kind of results, I don't know. But the educational system and the way we are being taught, and we don't have much idea about our own system, is really very pathetic. So now you see, now coming back to few place value. Can 100 BC. Okay, suppose there is a number 2,45,926 and you are writing it as 2 into 10 lakhs, isn't it? 2 into 1 lakhs plus 4 into 10,000 plus 5 into 1,000 plus 9 into 100 plus 2 into 10 plus 6. This is what is called place value. You see, the same 2 will have two different values. The first 2 will have a values of 2 lakhs due to its place, but the other 2 which is there, it has a value 20. So we have names for these powers, isn't it? 1 Eka, Dasha, Shata, Sahasra, Ayuta, Niyuta, Prayuta, Arbuda, Nyarbuda, Samudra, the modern million, Madhya, Anta, and Parartha, billion, 10 to the power 12. Then Panini's Ashtadhyayi has mentioned of 0 because there is a word called Lopa. Lopa means absence or disappearance. So people think that the origin of 0 has its root in Panini's Ashtadhyayi. Otherwise, how come that word Lopa is there? I will tell you how the Greeks really could not understand the concept of 0 and infinity. Simon Laplace, 18th century French mathematician, physicist, and astronomer, the Indian decimal system of place value like anything. He has told that this is one of the single most important contribution in the advancement of human knowledge. Shulva Sutras. Shulva means rope and Sutra means rules. That is rules for measurement. Can you imagine that Shulva Sutras dated back to 1800 BC, and you will find out the mention of Pythagoras Theorem in Bodhayana. Okay, and few of those texts or treatises which speaks of mathematics is Bodhayana, Katyayana, Apastamba, and Manava. I will tell you that this Pythagoras Theorem, all of you know, we ascribed this Pythagoras Theorem to Pythagoras, and you can find out the mention of Pythagoras Theorem in Bodhayana Sulabha Sutra, and which dates back to 800 BC. Now, how that is mentioned? The square on the rope corresponding to the diagonal of a rectangle. This is AC. AC is the diagonal. Okay. So the square of the rope corresponding to the diagonal of a rectangle So this AC, if you construct a square, the square is constructed, makes whatever is made by the squares on the lateral and vertical sides individually. So if you take a ABC, the diagonal AC, and if you construct a square, now the area of that square is equivalent to the sum of the two squares constructed from the two lateral sides, lateral and vertical sides, lateral side BC and vertical side AB, or in modern term, AC square is equal to AB square plus BC square. And this was mentioned in Bodhayana Sulabha Sutra in 800 BC. Now, Bodhayana Sulabha Sutra did not stop there. Construction of a square whose area is the sum or difference of the areas of two given squares. If two squares are given, then how to construct a square whose area will be sum of the given two squares, or whose area will be difference of the area of these two given squares? That how you are going to construct a square. That was there in Bodhayana Sulabha Sutra. Suppose a given square is there, and if you want to construct a square of area n times of that square, then those formulas and sutras were mentioned in Bodhayana. Transformation of a rectangle to a square with the same area, that was also there. Squaring a circle. The solutions involves, so can you imagine that unless somebody knows geometry and algebra, can he do all these kinds of things? Not only that, there was a mention of the square root of 2. How nicely the square root of 2 was found out, you will be surprised. So, and this method was the approximation method, and the value of square root was correct up to 5 decimal places. How they give a series. Root 2 is equal to 1 plus 1 by 3 plus 1 by 3 into 4 minus 1 by 3 into 4 into 3, 34. That is equal to 577 by 408. How that 577 by 408 could be reached is really a surprise. Probably there was a equation kind of thing like 577 square minus 2 into 408 square is equal to 1. And they have neglected this 1. So 577 square is equal to 2 into 408 square, or 2 is approximately almost equal to 577 square divided by 408 square, or 577 by 408 square. So naturally square root of root 2 will be 577 by 408. And if you divide it, you will get a value of square root which will be correct up to 5 decimal places. And this was mentioned in Bodhayana Sulabha Sutra. Now, another thing, in Pingala Chanda Sutra, which dates back to 300 BC, there is the number of metrical forms with gurus. Gurus are laghus in a prastara with n syllables. This is the number of ways in which r objects can be chosen out of n objects, and this is called binomial coefficient, isn't it? Suppose you have r objects, then how you are going to choose those objects, and those things we read in binomial, isn't it? So this was mentioned in PC, and this is a Meru Prastara which was constructed by 10th century, having informations from Pingala Chanda Sutra. So basic rule for the construction of a table of numbers referred to as the Meru of the so-called Pascal triangle. It is based on the principle that a number in any row, suppose you take the last row. If you take the last row, suppose this 6 is there. Above this row, there are two numbers, one to left and another to right. So 6 is 1 plus 5. Similarly, 15 is 5 plus 10. 20 is 10 plus 10. 15 is 10 plus 5. 6 is 5 plus 1. Similarly, the second row 5 is 1 plus 4. Third row 1 plus 4. 10 is 4 plus 6. What does it mean? In other words, if we have 6 objects, okay, there is only one way of choosing none or all the 6 objects. If you have got 6 balls, then if you are not going to choose any ball, then how many ways are there? Only one way. And what is the option available for choosing all the 6 balls? That is also only one. So that is what he is telling. In other words, if we have 6 subjects, there is only one way of choosing none or all the 6 subjects. 6 ways of choosing 6 balls of different colors. If suppose and if you want to choose one ball, then there are 6 ways. And 6 ways of choosing 1 or 5 objects. Similarly, if you want to choose 5 objects, you have got 6 ways. 15 ways of choosing 2 or 4 objects, and 20 ways of choosing 3 of them, 3 objects. So this is how this Meru Prastara is constructed, which gives rise to, which is the forefather of your binomial coefficient. Now, coming back to trigonometry, trigonometry in its modern form has its origin in India. For computations, the Indian Jia is far more convenient than the Greek chord. I have drawn 2 diagrams. You see the Indian Jia. If this is AO, this is B, AB. AB is the Indian Jia, isn't it? You see this AC. So, Jia, understand R sine theta. Suppose you will say that R sine theta is such a new word. But what was that sign in our literature? The word sign is linked Jia, or Jiva is another word for Jia. This was read as Jayab. This Jiva was read as Jayab in Arabic. That means pocket or fold, which was translated into Latin as a sinus. This later became sine, which we now use. So the sine thetas, if you trace its origin, you will go back and you will land at Jia, which was there in Indian. Now, Brahmagupta is another wonderful mathematician, astronomer. Brahmagupta Brahmasputa Siddhanta, 628 AD. Results, it has correlated results in algebra, geometry. The wonderful equation is the quadratic indeterminate equation. That is Varga Prakriti, x square minus dy square is equal to 1. You will be surprised to find that when I gave this equation to my brother for a mathematical programming, you are surprised to find that if you do a programming, then and then only you can find out the value of xy. D is an integer, and you have to find out the integral values for x and y, which will satisfy the equation, and you will get x square minus dy square is equal to 1. For d is equal to 61, if you are going to find out x and y, you will be really astonished that how they could come to such values of x and y. X will be 1766319,049. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 10-digit big number. And your y will be 22, 61, 53, 980. 3 to 5 to 7 to 9-digit big number. Then you can get x square minus dy square is equal to 1. And this was Varga Prakriti, the quadratic. You see the wording only. What is modern mathematics is telling quadratic indeterminate Siddhanta mentioned is at Varga Prakriti, where d is a given integer and one is seeking integer solutions for x and y. Brahmagupta gives a method to find many solutions of this when one solution is known using Bhavana procedure, composition law in modern mathematics. Bhaskara II's Bija Ganita used also Varga Prakriti and Chakravala algorithm. Okay, so Brahmagupta's Lilavati, I will give you one example of Lilavati also, Lilavati Sutra, Bija Ganita, Siddhanta Shiromani. Then the other mathematicians were Sridhara in 8th century, Mahavira in 9th century, Sripati in 11th century. Another 1 or 2 beautiful slides I will show you. Narayan Pandita in 14th century mathematician, combinatorics, magic squares. Madhava, I will speak few words about Madhava. Madhava of Sangama Grama, who is from 1340 to 1420, took the first significant steps in calculus before the subject developed in Europe in the 17th century. In my inaugural remarks, I have told you that calculus, we know that calculus originated in Europe by Leibniz and Newton in 17th century. But we didn't have any idea that it was already there, flourished in a very nice way by Madhava and perfected by Jashtadeva. And Jashtadev's book, Ganita Jukti Bhasa, probably the first book in the entire world on calculus. So Madhava get the infinite series of pi. I will tell you why it is so difficult unless you know Sanskrit, and that too in the most authentic and with an authoritative way. You will not be able to decode the messages that are contained in these verses. because I will tell you, once you have a mastery over Sanskrit, you will understand the beauty of poetry and the way mathematics and science of ancient India are being locked in those verses. So Madhava gave the infinite. You know what is pi for any art students. If you draw a circle, measure the circumference, measure the diameter. Diameter is the line passing through the center from touching one point of the circumference to the opposite point of the circumference. If you divide the circumference by the diameter, whatever the size of the circle may be, small circle, medium circle, or big circle, you will always get a number. And that number is not a fraction. You cannot, that number doesn't end irrational numbers. Okay, aparimeya sankhya. So this pi is such an irrational number, and pi has sustained that it has weaved its web of magic also to Ramanujan, isn't it? So Madhava, with a beautiful Sanskrit verse, I will tell you about this, how beautiful this Sanskrit. I was so mesmerized by this.
Hello. 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 Hello.
Just wait, just wait.
Okay.
Am I not audible?
Yes,
Am I
you are audible.
Am I audible?
Now. Yeah.
Am I audible?
Okay, continue.
Okay.
Okay.
So Vyase Baridi Nihate Rupahute Vyasa Sagara Vihate Trisaradi Vishama Sankhya Bhaktam Runam Swam Pruthak Kramat Kuryat. The diameter multiplied by 4 and divided by unity is found and stored. Again, the products of the diameter divided by odd numbers like 3 and 5, and the results are subtracted and added in order to the original result. So can you imagine that this first the verse, then the interpretation, and then the mathematical expression. So Vyase Baridi Nihate Rupahute Vyasa Sagara Bihate Trisharadi Vishama Sankhya Bhaktam Runam Swam Pruthak Kramat Kurjat. So this interpretation, if you translate it into modern terminology, it will become pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus like that, because then the results are subtracted and added in order. That means in alternately. Then you will get a value which will be equal to pi by 4. And what is that pi? That pi is the ratio of the circumference to diameter. This series is ascribed to Gregory and Leibniz in 17th century, who came 3 centuries later. Here, the Bhuta Sankhya system for representing numbers is used.
Sorry, sir.
Hello?
Sir, your presentation is not visible, sir.
Not visible. What is happening? Let me see. Just wait. Sometimes it is creating problem. Just wait. Okay.
You are visible, but your presentation is not visible.
Just wait. Is it visible?
Yes, sir.
Okay.
It is
Yes.
visible now.
Okay. So this series is ascribed to Gregory and Leibniz, 17th century, who came 3 centuries later, because Madhava from 1340 to 1420, that have the potential to connote number. Why Bhuta means beings, okay, and Sankhya means a number. Here, they have employed beings as numbers. Prithvi Rupa 1, Netra 2, Guna 3, Veda Baridhi 4, Bha 27. Later we will use the fact. Later we will go to another. So I will explain the Bhuta system Paddhati and how this Bhuta Sankhya Paddhati works actually. Thing is continued. This is Madhava was not happy with only this value of pi, so he tried to polish this value still further. So in another sloka, Vibhuda netra gajahi hutasana triguna. Why this? Just wait. Let me just wait.
It's visible and audible. No problem, sir.
Okay, just wait. Sometime let me first make my mobile.
Okay.
Just sorry. Okay. So Vibhuda netra gajahi hutasana trigumahava nava nikharbamite bruti vistare paridhi manamidam jagadur buddha. We will pause for some time and we will explain it in detail. What does this mean? First, the interpretation says that wise man, jagadur buddha, wise men say that if the diameter happens to be 9 into 10 to the power 11, which is called nava nikharba units, then the measure of the circumference is 28, 27, 43, 33, 88, 233. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. A 13 digit big number will be this circumference. So if the diameter will be 9 into 10 to the power 11 nava nikharba, then the circumference will be given as Vibhuda netra gajahi hutasana triguna veda bhava rana bahava. That is your circumference. So now you will see how this circumference, that is what is called bhuta sankhyapati, because these words will represent a number. How they will represent number? Ankanam bamatah gati. Arthat, we have to move from right to left. First we will decode the beings or the bhuta into numbers. We will read those decoded numbers from the right to left. To understand, the wise man says that if the diameter will be nava nikharba, 9 into 10 to the power 11, then the paridhi will be Vibhuda netra gajahi hutasana triguna veda bhava rana bahava. That will be your circumference. Now, how can that be a number? Three, Veda 4, Bha 27, Karana 8, and Bahu 2. So you have to read now. I have already decoded the beings into numbers. Now I will read these decoded numbers from right to left. So first I will read 2. So you see 2. Then 8. So 28 I got. Then 27, 27. Then 4, 3. 40, then 3, 3, 3, 3, then 8, 8, Ohi and Gaja, so 8, 8, then 2, Netra, 2, and 3, 3, Vibhuda, 3, 3, I got. So I got my paridhi or circumference as 28, 27, 43, 33, 88 to 33. When I will get this circumference, when my diameter will be nava nikharba, 9 into 10 to the power 11. Then I have to find out my pi by dividing the diameter with the circumference, and I will get this value 3.141592653592. And do you know, this value of pi is correct to 11 decimal places, and that was given by Madhava in 13th century. So the infinite series for the sine and cosine functions were also given by Madhava. Ganita Jukti Bhasa of Jashtadeva that I was mentioning gives the proofs for all the infinite series as well as efficient ways for obtaining very accurate values of pi. Book can indeed be called the first textbook of calculus. Okay, this is a history of exact results for pi. So first it was Madhava in 1375, then Francois Vitae, then John Wallis, then William Brunker, then Isaac Newton, Then James Gregory, you see, when Newton came in 1665, Madhava kept it in 1375. James Gregory 1671, Gottfried Leibniz in 1674, Abraham Sharp in 1699, John Machine in 1706, and Ramanujan infinite series could reach the value of pi to an unimaginable extent. Okay, so I think we should not go to this slide because I have got a lot of slides, so we should exclude. These are the development of mathematics up to Nityananda. Okay, who is so we should skip these slides. This one also. An overview of the development of mathematics in India. So mathematics in the ancient period prior to 500 BC, two things are important. Already we have discussed powers of 10 and sequences, including in the Vedas, and the Sulabha Sutras, which is recorded to 800 before 800 BC. Then mathematics in the classical period, which probably I will not take, except one I have taken, that indeterminate quadratic equations or Varga Prakriti. So classical period is from 500 to 1300. Panini's Ashtadhyayi, where we came across that Lopa. Then Pingala Chanda Sastra, where we have come that Meru Prastara. Holayudha's Meru Prastara, but before that the other metrics, how you are going to choose R objects from N objects. Those foundation stone was laid in Pingala Chanda Sastra. Then a galaxy of astronomer mathematicians starting from Aryabhatta, Brahmagupta, Lalla, Mahaviracharya, Bhaskara, Nityananda, Samanta, Chandrasekhara. Then indeterminate equations of the first and second order. Then mathematics in the medieval period. We have already taken Madhava's series for pi, the sine and of inverse trigonometric functions, not possible. And the modern period is Srinivas Ramanujan. So I will skip those things. Now, what prevented, I have mentioned you, what actually this idea, this concept of zero and infinite, the Greek minds. Okay, I have to be very, as I have mentioned you, another 5 to 7 minutes, I have to close my lecture. So what prevented Greeks from discovering calculus? This zero, which is Sunya, and infinity, Ananta, were never admitted by the Greeks. I also did not understand why they failed to, why they were so much afraid of this zero and infinity. Essence of calculus is use of infinitesimal limits. Greeks could not do this neat little mathematical trick. They did not have the concept of a limit because they did not believe in zero. Because you see, ultimately, what is the limit? Something delta t tends to zero. If I am finding out the differential or derivative dx by dt, that means limit delta t tends to 0, delta x by delta t. That delta t tends to 0 somehow did not enter into Greek mind, isn't it? So they did not have the concept of a limit because they did not believe in zero. The terms in the infinite series did not have a limit or a destination. So it will not converge. They seem to get smaller and smaller without any particular end in sight. As a result, the Greeks could not handle the infinite. They pondered the concept of void, but rejected zero as a number. That is what is the greatest contribution of the Indians. They have not pondered over they have not taken zero just as a void, isn't it? Professor Sarira Sahu was also telling that Sunya means not void for us. It's a number. They pondered the concept of void but rejected zero as a number, and they toyed the concept of infinite but refused to allow infinity, isn't it? All philosophical arguments were centered on infinite, but they could not develop the allow the idea of infinity. Numbers that are infinitely small and infinitely large could not. It always baffled the Greek minds. Anywhere near the realm of numbers, this is the biggest failure in the Greek mathematics, and it is the only thing that kept them from discovering calculus. That is Charles Sepp's book, Zero, the Biography of a Dangerous Idea, isn't it? So I should not, I will also skip this one. Indian approach to zero, infinity, and numbers in general. Unlike Greece, India never had the fear of the infinite or of the void. Indeed, it embraced them. Indian mathematicians did more than simply accept zero. They transformed it, changing its role from mere placeholder to a number. It's not a placeholder, it's a number now. The reincarnation was what gave zero its power. The roots of Indian mathematics are hidden by time. Our numbers, the current system, evolved from the symbols that the Indians used. By rights, they should be called Indian numerals rather than Arabic ones. Unlike the Greeks, the Indian did not see the squares in the square numbers or the areas of rectangles. When they multiplied two different values, instead they saw the interplay of numerals. Numbers tipped up their geometric significance. This was the birth of what we now know of algebra, isn't it? So this also I will skip. Lilavati's, Bhaskara's nice sloka is there. One thing only I will take here. This is a very beautiful problem pertaining to quadratic equations. With this, probably there was beautiful things on astronomy, but I will not have time. This I am just telling you how wonderful this is. Yatam hansakulasya mula dasakam mekha game manasam prodiyas talapadmini banamagat ashtam sakostambashtatat bale balam mrunal shalini jale keli kriyal alasham drushtam hansa jugatrayam cha shakalam juthasya shankhyam bada. You see how beautiful the verse is. Sardula Vikreditam. Of a herd of swans at a water body, 10 times the square root went or migrated to Manasa Lake. On the approach of clouds, when clouds came, 10 times the square root of a herd of swans went or migrated to Manasa Lake. 1/8 having flown, went to a forest of Stalapadmini, Hibiscus muta, from the shore of the water. 3 pairs of swans were observed in sporting in water. Keli kriyal alasham. Okay. 8 stalks of lotuses. O girl. Drushtam hansa jugatrayam cha shakalam juthasya sankhyam bada. O girl, can you see the beauty of this verse and how nicely a quadratic equation is hidden in this verse? That is really, that speaks of the brilliance of Indian mind. Okay, now in the next slide, I will show you. You see, now I am translating it into the mathematical forms. The given problem is as follows: x square is equal to x square by 8 plus 10x plus 6. Then you do it like this, then you will be left with this equation. Applying the solution for quadratic equation, then you will get x square is equal to 144. There were 12 swans. You see how many swans they fly and how many remain. All these things in Lilavati Sutraj. Okay. Similarly, summation of series, there are so many beautiful verses, and again interpretation in words and also expression, mathematical expressions, but we don't have. And study of magic square is one of the most important thing of ancient India, that is Bhadra Ganita. And I will show you at least 1 or 2 squares. You see, this is a normal magic square. If you add the columns or the diagonals, principal diagonals, you will get 34. But here the pan-diagonal magic square. That means if you add 10, 11, 7, 6 broken diagonals, all okay, like 3, 5, 14, 12, also you will get 34. So this is the realms of Bhadra Ganita. And actually, I could only touch the rudimentary of mathematics, and there lays lot of astronomy is still there. Normally, people had an idea that astrology and astronomy in India, in ancient India, was almost the same word, because at that time the astrologers were not like the modern astrologers. All astrologers in ancient India were astronomers. That is what is the qualification required to undertake study of astronomy. Bhaskara has mentioned in Goladhyaya of the Siddhanta Shiromani, commenting on eligibility criteria to study astronomy. Observe. Jo Veda Badanam Sadanam hi Samyak Brahmaya sa Vedam api Veda Kimanya Sastram Jasmadata Prathamam Etaditya Dhiman Sastrantaraya Bhavati Sravane Adhikari. So what should be the qualifications in order to read astronomy? And the mere astrologers were criticized. Actually, they were not given importance without the computational skills. So all these things were there. Now let me come to the most probably the last part of our slide. Why should we read actually? That is very important. Situation of the earth, the rudiment of gravity was also there. The force of attraction exhibited by the earth. Akrushta saktischa mahitaya jat kastam gurum swabhimukham swastatya akrushyate tatpati tueva bhati same shamannat kavo patatyam khe. The earth is known to be possessing the power of attraction. All the heavy objects in the sky are attracted towards it by this power. That is why they appear to be falling. This phenomenon is uniform all around the earth. This being the case, if the earth itself were to fall being unsupported, where would it fall in this space that was there? So, but one should not extrapolate and say that this is the theory like this, or I am not telling that theory of gravitation was hidden here, but the idea was there. A lot of intellectual practices were going on. Why we should read? I probably 53. So you see, and I was exposed to a seminar where lot of beautiful things were there in Indian universities like Takshashila, Nalanda, Ballavi, Bikramshila, Udantapuri, Jagaddala, Shomapura from 6th century BC to 12th century AD, and a lot of other things were there. Probably I will, with our Pathani Samanta and Siddhanta Darpana, I will complete my lecture. As I have mentioned you, I have got a important assignment at 1, so I have to leave. Otherwise I would have told you so many beautiful things on astronomy also. The Copernican model has some flaws that are absent in Nilakantha's model, which is very similar to Tycho Brahe's 1580 model. Chandrasekhar Singh Samanta or Pathani Samanta, an Indian astronomer, the last Indian observations of the moon and the planets using simple instruments designed by himself. Actually, and you know, while going to Nayagarh, there is Khandapada, where Pathani Samanta was living. Based on these, he made many innovations within the Siddhantic tradition, and these are described in his monumental treatise named as Siddhanta Darpana. Planetary model is similar to that of Nilakantha and Tycho Brahe. So, so this is, you see, the Indian knowledge system gradually these days, it has become, and all of you should know that Indian knowledge system is a vast ocean. So many things are there. You see, language, linguistics, literature, and there are so many experts also. But I don't, so I should stop here. My acknowledgement is to Professor M.S. Siram and Professor K. Subramanian. I have used some of their slides, and Professor M.D. Srinivas also, though I could not touch his slides, and Sri Sri University also. Giving me an opportunity, and all other organizers, and thank you, Dr. Principal of the Jawaharlal College. Okay, so unfortunately, because 15 or 20 minutes of my time was in Sarira, so I have to.
You have to come again.
Anyway, just 1 or 2 minutes, because immediately I have to log on for another class at 1 o'clock.
Okay.
So
Okay.
Thank you.
This is a very interesting topic, and once the physical mode started, I will be very happy to go to Patnagarh College and give a lecture. Actually, all of us should know about this. This is very important.
Yes. Thank you so much. Thank you so much, dear friend. Now this is time to wind up today's business, and I request our IQAC coordinator, Professor Arti Panda, to propose a vote of thanks.
Yes. So I am taking leave of all of you.
Yes.
Namaskar.
Bye. Namaskar. Bye.
Am I audible?
Yeah.
Okay. A very good afternoon to all of you. Esteemed head of the institution, our principal, Dr. Devaraj Misra sir, respected resource persons, and respected HOD physics, and dear participants. Today's day was really a day of learning, as all good things come to an end. So in this webinar also, it is really a pleasure for me to end such a beautiful event with a vote of thanks. On behalf of the Jawaharlal College Patnagar, I take this opportunity to propose a vote of thanks. First of all, I would like to express my sincere thanks to Professor Sarira Sahu sir for taking out his time from his busy schedule and giving deep insights into the topic Messengers from Heaven. Thank you so much, sir, for joining us and sparing time for us. I also extend my thanks to Dr. Nachiketa Khamari Sharma sir for giving a beautiful talk on the topic traditional science and technologies of India. And personally, I enjoyed a lot because I belong to the Department of Mathematics. We really enjoyed listening to you, sir, and as a resource person in the webinar. Thank you very much, sir. And in future also, we will